so today we're going to talk about converting your game to the data-oriented technology stack, or DOTS. And again, my name is Mike Geig. I'm an evangelist at Unity Technologies. And so let's take a look at how this works. Now again, quick just sort of a disclaimer. Twice today I've had a blue screen on my laptop. I think a driver update fixed it, but let's just strap in and see what happens. Hopefully we don't get any crashes. So here's what we're going to be talking about. We're going to be talking about just sort of these main things about the data-oriented technology stack. So an overview, the what, what's our goal, when would we implement this, and more importantly, most importantly, how do we implement it? So who here has tried to use Unity's entities, ECS or DOTS or whatever you want to call it? All right, who here has been frustrated trying to use ECS or DOTS or entities or whatever you want to call it? Fantastic, that is completely accurate. Who has just found it super easy? I'm sorry, let me rephrase. Who's a liar? Yeah? Okay, fantastic. So the data-oriented technology stack, let's talk about what it is, why we're doing these things, and how we do these things. So DOTS. So you may have heard this term DOTS recently. And so if anyone's familiar with the C# job system or the entity component system, the burst compiler, Project Tiny, we've had these things for a while now, some of them longer than others. And what these really are together is what we are collectively referring to our technology stack. That's DOTS. So when I say we're using DOTS, it could be any of these things because we're adding more and more things to this, right? We have the new Havoc-based physics and things like that, and we're just adding things to what we're calling our DOTS. And so that's what this all kind of means. And so why would we integrate into DOTS? Why bother? I don't know if anyone's seen Megacity or some of these other things. You think, oh, DOTS is just when you want things to run really fast. And that's sort of true, but not necessarily true. DOTS is basically whenever A, performance is really important because you want to go extreme, or B, performance is important because you want to conserve. Right? You don't need massive amounts of performance if you're making some mobile device, game, some novelty game, some casual game, some whatever. You may think, well, DOTS doesn't make any sense for me. But that's not actually the case because what DOTS effectively enables you to do is reduce memory consumption, CPU usage, battery consumption, and thus make your game run a lot better on these platforms. So effectively, this is your brain on drugs. This is your data on monobehaviors. And this, again, broad just sort of generalization here. But with classic C# classes, monobehaviors, you're using these reference objects, and they're scattered all over in memory. And when you need to load something onto the CPU's L1 cache to do some work on it, first you need to go find it. And generally, when you get to that memory address to grab this thing, it contains a reference to another memory address that you need to go there, and then so on and so forth to pull all this data into the CPU. And it causes a lot of cache misses. It causes just a lot of slowdown, bottleneck, a lot of just issues, right? And that's just the way C# classes, that's the way this sort of memory stuff works. It's just how it is, right? And so we're looking at how can we get beyond that? How can we start thinking about our data differently in order to effectively make our memory look at like this, where all of similar objects, all things that would need to be loaded into the CPU, are all tightly bundled together in memory chunks, so that when we need them, we know exactly where they are. We can prefetch all the next ones and so on, right? If anyone loves organization, this slide is like, yes. This is effectively what we're trying to do. Again, really oversimplified, but we're trying to keep all of these things together so that we can iterate through them. So when it comes time to process them, we can just load them up. Now, it doesn't actually move all your memory to be sequential like that, but this is how they're processed. It just knows where they are. It can sequentially start grabbing this one, then the next one, then the next one, then the next one, so that when it comes time to perform any operations on them, we can do so in sequence quite easily. Now, this is all the concepts if you're just using ECS, and this is just one thread or one core. But we also have the job system, which enables us to do this all in parallel, distributed across many, many cores. I don't know if anyone else has noticed this, but CPUs haven't gotten faster in 10 years, right? There was a time where we're like every month was something new, and now we haven't seen it. We're bottlenecked 5.3 around there gigahertz, and that's about where we live. So what do? We add more cores. Well, if you're not utilizing those cores, what's the point, right? You have the same processor from 10 years ago. And now you might buy this special type of hardware, you have these special type of platforms or whatever, but most multi-thread code treats it all exactly the same. And so you don't really optimize your performance until you use something like the burst compiler, which takes advantage of all the really cool bits that every unique platform has. Some platforms handle certain types of math one way versus another, and the burst compiler lets us take advantage of that to make some really performant, really fast code. Now, I'm not doing all this in PowerPoint. We're actually going to go into the editor, which is why I'm talking quickly, because we're going to write some code and see exactly what it is that I'm talking about. So when do we integrate dots? All right, so I can't iterate this enough. Dots is not a complete product, not even close. Dots is something that we are actively working on. We encourage everyone to try it, we encourage everyone to learn it, but there are many pieces that do not exist yet, right? They just don't. And so when we're talking about when to implement dots, you, at this moment, implement dots to solve specific problems. I'm doing something and I've hit a bottleneck and I need to get past that bottleneck. Maybe dots is a solution to get me past that bottleneck. Maybe it's not. It depends on what the problem is, right? But we want to solve specific problems that come about from technical hurdles, right? And that's very, very important. We also want to implement dots incrementally. Assuming you're not starting with a brand new empty project, assuming you have a project you're already working on, chances are you're not just going to go, you know what, that's it. Let's scrap all game objects and go directly to 100% dots right now. That's just not feasible, all right? And so today we're going to look at how we might just change part of a project to dots, dip our toe in, or dip in dots, as I like to call it. Oh yeah, there's more. And so it's also important to have a very solid understanding of our limitations and roadmap. What's not here yet, what's coming, right? So before, I was talking about how we don't have physics. Last time I've delivered this talk, well, we do now have dots physics, but we don't have a dots animation system, right? And so I have a game where my player animates. Well, I can't use dots for that right now because dots doesn't have an animation system. So I have to have a clear understanding of what our limitations are, what I can do, what I can't do, and then make a real decision from there. So basically, as long as you think logically and make sure data is at the center of your decisions, you'll be good. Now, I specifically added this slide for Unite-Shanghai because they had no idea what I was talking about. And I got to explain and have the translators tell everyone that this character's name is Data, and that makes it funny. And they still didn't laugh. But also, I just noticed today, ignore that it says Shanghai on there. This is Sydney. You are in the right place, so don't worry about that. So let's look at some real code. And by real code, I mean images of real code. For now, we will get in the editor in a moment. So let's say I made the decision to switch to dots. And these are three monobehaviors, three prefabs that I have. A player, an enemy, and a projectile. And I start thinking, okay, dots is all about the data. So let's start looking and analyzing our data. How will I structure the data for these three unique things? Okay, well, it's very clear to me that I have a player that's got some unique set of data, I have an enemy that has some unique set of data, and I have a bullet that has some unique set of data. So I can very easily say, okay, well, let's create a player data component to encapsulate all the player's information, the enemy data component to encapsulate the enemy's information, and the projectile data component that encapsulates the projectile data, right? Makes sense. Very straightforward. Okay, you're all wrong. That is absolutely incorrect, and this is why most people have a really hard time flipping that switch and using something like UCCS, something like entities, something like dots, right? Because this makes sense. This is how you've been doing it forever, and this is completely not the way you should do it, right? Because what do we have here? We have a whole bunch of redundancy, right? Not to mention that if I want to move a player, just move the player, well, what do I need? I need the player's position, their rotation, and how fast they're moving. I don't need their camera, I don't need their rigid body, I don't need their animator. Why would I clump all that data together and load that all onto the CPU when all I need to do is move them with a few small pieces of data? So instead, we're going to look at data like this. I'm going to create something that's called a MoveSpeed component, right? And that's all it contains, just a value that defines MoveSpeed. I'm going to create a health component, and that's all it contains, just health data. Now, I also have rigid body on here, which we don't really have rigid bodies with dots physics. I'm just really trying to drive home a point. But we're looking for redundancies, and we're creating individualized pieces of data so that on an enemy entity, I can put a move speed component and a health component and a rigid body component, even though that doesn't exist, or so on and so forth. And that's what we're going to do. Just like we have components in monobehaviors now in the engine, where you just stack all the monobehaviors you want. In this case, we're talking about component data. We're going to do the same thing. these small atomic pieces of data that we're just going to stack up to define what something looks like, what data defines it. And again, these components are all data, no logic. I don't anywhere on my entities define what this data does. It's just data, all right? So let's look at another example. This one's a bit different. Now let's look at some functionality. So here I have the thing that moves an enemy and the thing that moves a bullet, all right? And in this case, the way my enemy moves and the way my bullet moves are different. My bullet moves forward at some predefined speed, as where my enemy has to steer itself towards my player. So it has to turn itself and then move towards its intended target. Now in this case, since these are different, that they move differently, it's easy to see that these would be two separate systems, because an enemy needs to turn and then move as where a bullet just moves. All right? So that should hopefully make sense. And that is absolutely incorrect. Again, completely incorrect, and one of the reasons why we always mess this up, because there are two systems here. That part is correct, but we have one system that moves something, or turns something. It doesn't have to be an enemy turning towards the player, it just turns something, and whatever meets that criteria turns. And then we have another system that moves something forward. And again, it doesn't really matter what it is, because the way a bullet moves forward, and the way an enemy moves forward, and the way a player moves forward, and the way anything moves forward is exactly the same. So I will not define systems for all of this redundant behavior. I'll have one system, the move forward system. I'll have another system, the turn towards system. All right? And then I can just set up my entity data to determine which ones get used by which system, and everything just works correctly and quickly, right? So that all bullets and enemies can move at the same time even. Who cares, right? Now, we have one more here. This is how the enemy collides and how the player collides. And so we can see here that this is, now that we all know that I'm playing some games here, we can see that this is obviously one system because they're basically the same. The way an enemy collides and the way the player collides is basically the same. It's going to detect if it's collided with the right thing, and then it's going to do something about it, reducing some health, and if the health is low enough, it's going to kill something. Now again, that's not the case. This is two systems, right? One system to detect the collision, that it says, okay, these things have collided with the thing we care about, and then another system to say, so what? They collided, now let's see if they've died. Or if they have died, let's clean them up and do something to them. Because each of these things requires different stuff. In order to detect collision, I don't need your health. And in order to kill you, because your health is 0, I don't need your collision data. No one system should load up both pieces of data at the same time, because you don't need both, right? And chances are, if I'm going to remove something because it's died, I'm removing it pretty much the same way no matter what it is. I'm probably just destroying it or whatever, right? And so I can add maybe some customization there, but the fact of the matter is, again, I'm looking for atomics, the small granularity. How small can I make these things so that they're reusable, extendable, all this really cool stuff? Now, I know that seems like a lot, right? But let's look at this in action in the editor with an actual demo. And so I'm going to go ahead and open up Unity here. And so I have AngryBots 2, which is a project we made. In this case, I've renamed it Angry Dots, right? Because that's an obvious win. Yeah, that's right. I always forget about that. Good. That was faster than last time for those of you who followed me over here, so well done. You're learning. All right, so I have Angry Dots 2. And so what I have here is I have a game that's all Monobehaviors, all game objects. That's it. I'm shooting game object bullets, as I can see over here in my hierarchy, and everything works great. I have no reason to implement dots in this project whatsoever. So right now, this talk can just be done, right? I have no reason. So let's introduce an unnecessary hurdle into our development. So let's say I need to use a spread shot, and that spread shot is going to generate a grid of 20 by 20 bullets, so 400 bullets 10 times a second. Now, I would say to whoever made that decision, well, why would I use bullets? Why wouldn't I use particles or something like that and simulate this? And they're going to say, I don't know, I'm dumb. Just use game objects. We need game objects. This is an example. Don't overthink it. All right. And so I need 400 game object bullets. And so I'm going to hit play. And now I have a bottleneck. Generating 400 game objects and shooting them out in a grid is difficult, right? It's a problem. So what I'm going to do, and this is part of the new preview 30 of the entities package, is I'm going to convert this game object into an entity. Now, before previous iterations of this talk, I've had a game object that was, or prefab that was my game object version, and a prefab that was my entity version, but we no longer have to do that. So here's something cool. So I'm going to go to my prefabs and look at my bullet prefab, and I'm going to see that I have a projectile behavior, capsule collider, rigid body, all these things. This is just a game object. There's nothing entity specific about it. And so I'm going to go to this projectile behavior, Monobehaviour. Again, that's it. It's Monobehaviour, nothing special about it. And I'm going to make this Monobehaviour work both for a game object and convert it to an entity if I so choose. So I'm going to do I convert, and you're going to watch me live type here, so I'm going to make a lot of mistakes. I convert game object to entity as an interface, and then I'm going to tell this to, hey, implement that for me. And if I come down here, it's going to create this convert method. So this convert method is called behind the scenes. It says, how do I convert this game object to an entity? How does the data on it now translate to these data components you already have? Now, in this project, to save time, I've already set up some systems and some data components and stuff based on the slides we just saw. So now all I have to do is provide them. So here I'm given an entity manager, and I'm just going to say, hey, entity manager, I want to add a component. So I'm just going to do add component, and I'm going to add it to this entity. And it's going to be the type of, and so this is going to need a move forward component. And that's the thing that tells the move forward system that this bullet moves forward. Okay, pretty straightforward. I'm typing all sorts of things wrong right now. Okay, new laptop, new keyboard, just getting the feel for it. Okay, so there we go. So that's my move forward component. I'm also going to say, okay, well, I need a move speed component, which I'll just call, move speed. There we go. Equals a new move speed. And these are all components that I've set up previously. This move speed just has a single thing in it called value. And I'm just going to set that to the speed of this Monobehaviour, right? So there we go. So there's my move speed. And now I'm going to say, hey, entity manager, I'm going to add some component data here. And so I'm going to add it to my entity, and I'm going to add this move speed that I just generated here. And so that's very simple there. And then finally, this bullet needs to destroy itself after a period of time. So I'm going to create a time to live, which I'll call TTL. Equals new time to live, and inside there again just has a value, and that's going to be equal to this lifetime that's on my Monobehaviour, this lifetime float. And then I'm going to say, hey, DTS or DST manager, we're going to again add a component data to my entity that is generating for me. It's flickered behind me. I hope you can still see it, and that's just going to be my time to live. There we go. So that's it. This defines that I'm going to go ahead and say, let's look at move speed real quick here. So go to my definition. Move speed is just this, serializable. Move speed implements iComponent data, has a value. Data, pure data, no logic. Move speed, how fast? Done. And so all I'm saying is, well, this bullet needs one. I'm moving ahead of myself there. This bullet needs one, so here's move speed with a value, and this entity now has it. This entity has a move forward and a move speed, so my move forward system is going to take it and move it forward, right? Generically, it doesn't care that it is a bullet or so on, and some time to live, and so it'll get called and things like that. So again, my prefab for my bullet doesn't change. It's still Monobehaviour, game object, whatever. The script doesn't look any different. It still works as a game object, but now it'll work as an entity too. Well, how do I turn this into an entity? Well, I could add to this a convert to entity component, and which would take this bullet and automatically convert it to an entity at runtime. However, I don't want just one bullet that's an entity. I want to create a bunch of them. And so I'm going to go to my player shooting script, and my player shooting script has this Boolean called UCCS, and I have some code already in here. So if I'm choosing UCCS, it's going to grab an entity manager from my world.active.entity-manager, and it's also going to call this game object conversion utility .convert game object hierarchy. And I'm going to pass in my game object Monobehaviour bullet prefab, and it's going to turn it into an entity prefab, which is of type entity. Just converts it right there at startup, says, hey, take this prefab, turn it into an entity, hold on to that because we're going to make a bunch of them. And there we go. So now let's shoot them. So I'm going to come down here. I have this spawn bullet ECS, and I'm going to create a new entity. So entity, which I'll call bullet, equals, and I'm just going to say manager, which is the name of my entity manager, .instantiate, right? That should look familiar. And I'm going to instantiate this bullet entity prefab. There we go. Now, I could try to instantiate the bullet prefab itself, which would convert it, but I want to do that every time I shoot. I'm going to do the conversion once and store it, as opposed to converting it over and over and over again, which would just slow things down. And so once I've done that, now all I have to do is just set some data. So I'm going to say, hey, manager, I want you to set some data for me. And it's going to say, well, what do you want to set it on, Mike? I'm going to say, great question. I'm going to set that on my bullet. I'm going to give that a new translation. Translation is basically what we just call position now. I don't know why, but that's what we do. So I'm going to say translation, and its value is going to be equal to our gun barrels.position. There we go. So there we go. So that's just going to place that there. And it helps if I spell things correctly, like that. Okay, and then I'm also going to say, hey, manager, let's set some more component data. There we go. Again, on our bullet, let's give it a new rotation. All right, and I am going to say for this rotation, value is going to equal, and everyone's favorite quaternion dot Euler, there we go, of our rotation that's passed in there. So there we go. So just like a game object where I instantiate a game object and I set its position and I set its rotation, I'm just instantiating an entity and giving it a position and a rotation, or in this case, we call it translation. So I'm going to come on back here to Unity. I'm going to click on my player. Sorry, I'm talking fast. These talks have limited amounts of time. And I'm going to check use ECS. And I'm going to hit play. And I'm going to see that I am now firing entity bullets. We don't see any bullets over here in the hierarchy. Entities don't show up in the hierarchy yet. Eventually, we'll have all the same workflows and UI and stuff. But for now, I'm firing entities completely indistinguishable from what I had before. Great. Now, let's tackle the spread shot, which I'm actually just going to grab these here and cheat. So here's my spawn bullet spread ECS. And so instead of generating one entity at a time, I'm going to create a native array, which is one of our new array types of type entity, which I'll just call bullets. And I'll say equals new native array. And inside here, I need to tell it how many. So I have this total amount to say how many of these entities I'm going to need and what type of allocator. And I'm going to do allocator temporary job. I could also do a persistent if I wanted, or invalid if for whatever reason I wanted to create just an invalid memory right off the bat, but I do not. So the new native arrays are awesome. They're fast, they're thread safe, which is amazing if you're working with multi-threaded code and stuff like that. You can write to them and everything, and they're not going to break and everything. It's awesome. But I do need to make sure I dispose them, or else I will get a memory leak. But it will tell me. But I'm just going to do bullets.dispose down here where I'd be done with it. And so then I need to fill this array with some created entities. So I'm going to say manager.instantiate, but instead of creating a single bullet, I am going to pass in my bullet entity prefab there. And I'm also going to pass in this bullets array, which will then get filled with bulleted entities. Now this is all boilerplate for loop code that basically creates a grid. And so down here, I'm just going to paste that, because for each bullet, I need to set its position and rotation. And so I'm going to do manager.setComponentData. And here, I'm just going to say bullets subindex, because it's now a list, or an array. There we go. And then for my rotation, it's going to be bullets index. There we go. And instead of the rotation for my whole character, I've created a temporary rotation for my spread shot, because it's creating a grid of all the stuff. So again, fairly simple. Basically 4 lines of code, 5 if you count the disposing of the collection. But now I'm generating a bunch of entities. So let's see if I've bypassed my hurdle. Spoiler alert, I have. So I'm just going to turn on spread shot, and let's see here. So I'm just going to go ahead and start shooting. OK, easy enough. But this is dumb, because this is 400 bullets 10 times a second. Let's do 400 bullets 100 times a second. OK. Let's do 1,600 bullets 100 times a second. Let's do 2,500 bullets 100 times a second. Let's look at the profiler. Profiler, what do you think? I think you're good, brah? 60 frames a second. So 2,500 dips me below 60 frames a second. So let's be reasonable and say 1,600 100 times a second. And there we go. 60 frames a second on a laptop. Sure, why not? Okay, so I've solved the problem. Let's create some enemies. So I have this enemy spawner, and on here, I already have it set up to use ECS, the same as I did with the bullets. It's an enemy prefab that I just put that conversion on, whatever, and so that's going to spawn some enemies, and I'm going to hit play. And the enemies are going to move forward with the same system that my bullets move forward with, but I have a problem here, and my problem is that my enemies aren't chasing me. And I say, hey, pay attention to me. Whatever. They're not chasing me. So let's create a system. All right? So obviously, I already have a move forward system. That's what makes my bullets move forward. That's what makes my enemies move forward. But I need them to rotate, to face me. And so I'm going to come here, and I have a turn towards player system script already created that is basically empty at this point. And so I can see first thing is I need to define some order to this, because then Unity is going to try to order these for me on what it thinks is reasonable. But I want to tell it, hey, I want this system to run before my move forward system so that my enemies turn and then move forward, as opposed to moving forward and then turning or some arbitrary order. So I'm just going to say, hey, this is going to update before that move forward system. And so, and ignore this commented out, I just didn't want to type this again. So this is a normal public class, and so I'm going to make this actually be a component system here. So I'm going to create actually a job component system. So I'm going to use both ECS, which is the system, and I'm going to make it a jobified system so it'll run across multiple threads, right? And so that's I'm going to define a job and then what this thing does. And so inside here, let's first, well, it's going to freak out here that I haven't actually implemented this. So let's tell it to implement that abstract class. So it's going to create this on update for us that says, hey, you didn't do it yet, which is fine. And so let's define a job. And so my job is jobs are of type struct, which I'm going to call this turn job. All right, and what type of job is this? Well, jobs or systems basically have two parts. The query, what data am I getting to work on? And then the execution, what am I doing to that data? Think of entities, ECS, all this stuff. Think of them like databases. I'm just putting in a query. Find me all entities with this row and this thing and that thing. It gives me a data set. I do something with the data set and I put it back. And it's as simple as that. So here I'm going to do an I job, all right, for each. Okay, for each what? Well, for each entity with, and now I'm going to say find me each entity that has translation, okay, and rotation data on it. Okay, and it's going to say, hey, you haven't implemented that, and I'm going to say, thanks, Visual Studio, nice catch. All right, and so that is going to create this execute method for me, which I'll come back to in a second. Now, that's going to find automatically, I don't have to do anything else, all these entities for me, right? That's good. I still need one more thing, though, because this is the turn towards player. I need to know where the player is. Now, this job can't just be like, hey, where's the main player? Because jobs aren't on the main thread. They don't have access to all the Unity stuff. So I need to pass into the job the position they're all turning towards so they can do that. And so I am going to create in here a public float3 player position, or player pause, if you will. And so down here is the execute method where I'm reading in the results of that query, the translation and rotation. It so kindly named these some obscure thing for me. So I will just rename these to pause and rot for position and rotation there. And I will delete this exception. Thank you very much. And so what am I going to do? And now I actually just copy pasted this here because I didn't want to retype it, because this has nothing to do with the job itself. It's all boilerplate. This is just the code that makes something rotate towards something else. Also helps if I use the correct variable names. So this creates a heading by subtracting one vector from the other, or a float3 versus a float3, which is 0 out the y, so the enemies don't head towards the ground or up towards the sky. They're always moving perfectly horizontal. And then we just write to the rotations value with, hey, just saying, look at this way, look at that way, whatever, and it just rotates. That's, this is just boilerplate stuff here. So, okay. And so that is my job. It's going to find everything with translation rotation. It's going to read in a player's position. It's going to rotate everything to face that position. Cool. Now let's go to on update here. So on update is going to say, all right, well, let's schedule one of these jobs. So I'm going to start off by saying not that. I'm going to start off by saying if, and then I have a singleton in here called settings. So I'm going to say if the player is dead, then I'm just going to return out of here because there's no sense in trying to turn towards something if it doesn't exist anymore. But then I'm going to say, all right, let's create a new job. So variable job equals new turn job, which is my job here. And inside turn job, I just need to tell it what data I want it to have. And my arrow keys are in different positions than I'm used to. There we go. So what data do I need to pass in? I only need to pass in one thing, my player's position. This stuff will be found for me. All of the entities and everything, that's all part of the query. That's done. I just need to provide the stuff that I've said that I need for this job here. And so I'm just going to say my player pause is equal to my settings again. Hello, settings dot player position. So that's just a singleton that keeps reference of the player for me to make this part really easy so I don't have to type a bunch of stuff here on stage. And so that defines a job. And now all I need to do is schedule it. So I'm going to say return job.schedule. And I'm going to say, hey, schedule this. All right, and I have these input dependencies that I read in as part here. I'm going to read in these input dependencies and pass them in as an argument, and then I'm going to return the job handle that comes off of this. That's how Unity sets up the timing. So the input dependencies says this job will start once this one's done, and so on and so forth, and that's how they all get linked together. But here is a system. Okay, I've written a full system. It seems like a lot of code to just make one thing turn towards the other, but not if you consider that this will make anything turn towards anything else. So if I had a whole bunch of things that needed to turn towards stuff, I wouldn't need to write it once in the enemy script, and the next time in this script, the next time in this script. You're writing all this code again and again and again anyway. Now it just works. It just turns towards something. All right. So I'm going to come back here to Unity. Now I'm going to let you know that this doesn't quite work right now, and that's intentional. Sort of works. Let's take a look. This is a common pitfall. You do this, you think, perfect. Enemies are chasing me. Fantastic. Let's shoot them. Oh, that's a problem. My bullets also have position and rotation, or translation and rotation. They are also turning to face me. That's a problem. Not so much if you think about it, because you can actually just create a shield of bullets and become invincible. So, you know, take that for what it's worth. Bug or feature, your decision. But there we go. OK, so sure. Let's fix this real quick. Now, all my enemies have an enemy tag on them. It's a data component that's empty. There's no value. There's no data in it whatsoever. It's just a component just for the sake of this, for the sake of identifying it for our different systems. So I could put the enemy tag here in my query, but that doesn't make a lot of sense from an efficiency standpoint, because I don't want to actually query that data and receive empty data. That's just unnecessary. I'm not using it for anything. I just need it to be there as a requirement. So instead, what I'm going to do is this, I'm just going to use an attribute here, which is going to be called require component tag. If I did that correctly, there we go. And then I'm going to say type of, and inside here, I'm going to say enemy tag. Now, I just named it enemy tag because that's the naming I use for any component data that's empty. I just call it tags. And there we go. So now it's going to say, hey, find me everything with translation and rotation and has that enemy tag. I don't need the enemy tag. I just want to make sure they have it. And that's what that attribute does. I also want this to burst compile, right? Because why not have free performance? So I'm just going to say burst compile. And that is literally all that's required to make the burst compiler work, which is awesome, which gets us like 40 times more speed on our jobs for free, which is super duper cool. So I'm going to come back here. And now what I'm going to see is that my enemies are going to chase me, and my bullets are not. As soon as I hit play, let's find an enemy here. Say hello to my little friend. There we go. OK, so enemies chase me, bullets do not. Now, one of the cool things, again, this is all kind of ECS, right? This is all dots. So I basically took this hurdle, and not only have I bypassed the hurdle, but I've given myself so much more leeway. So there's no reason I really have to use that spread shot. I could not use the spread shot, just use a single bullet using entities. Again, I'm not trying for quantity, but now it'll just run that much faster. So if this is a mobile game, I'm using that much less CPU. I'm generating that much less heat. I'm using that much less battery. I don't have to push this to extremes, but I'm going to. So I'm going to come here, and I'm going to set this to do one every 100 second, or 100 times a second. Let's do, I don't know, 30, so 900 bullets 100 times a second. Let's go to my enemy spawner, and how many spawns per interval? So let's do every interval will spawn, I don't know, 74. But our intervals are going to be every third of a second we'll spawn 74 of these bad boys. I don't know. Let's see if that actually runs. So a lot of enemies. Cool. A lot of collision detection. Not a problem. OK. We could probably go higher with this. Come in close, my pretties. OK, so a gratuitous amounts of violence. We may need a rating on this, but come on. OK, yeah, not even a problem. Let's just put on my profiler here. So I'm at 200 frames a second now. I do this, and it goes to just a little under 100 frames a second, still somewhere around 80 frames a second. Collision detection and everything. Not even a problem. All right, so fast, if I want it, but I don't have to. Right? And the cool thing about this method of doing this is, let's say, again, this is the concept of I have a game in the works, right? I'm just sort of trying this out. Maybe it doesn't work, right? Maybe ECS is not doing what I needed to do. Well, great. I'm just not using ECS anymore. That's one of the cool ways of setting it up like this, where I'm just, OK, I'm back to just using game objects. And I'm not going to try to hit play right now, because there's not a chance in hell this will run. But it's kind of risk-free to use this new conversion stuff, right? And then once I'm satisfied with this, I can then make it more permanent. I can then add more. I can grow. I can iterate. I can expand on these things that I want to do. But it's very, very fast. So I'm going to end with this, because I want to leave time for questions for the next person to come up and stuff like that. This is something brand new. So I showed this talk at GDC. I don't know, has anyone watched this talk from GDC? It was a shorter version of it, a few of you. So a lot of people immediately followed up with, well, where's the code? I want to try it myself. So I thought, well, yeah, I bet you do. So here we go. So I've put it online. You can all download the code for this whole project. Try it out yourself. This is brand new. I put it up like 2 days ago. So feel free to check it out. github.com/unitytechnologies/angrybots_ECS. Try it out. Let me know if you have any questions. Now, this is using very simplistic physics. It's not using dots physics because I'm just trying to keep the example as simple as possible. So I'm doing simple radius checking and things like that. But you'll see how I set up the prefabs, how all these systems work, how all this component data works. And one of the cool things that I would ask you to do is try to add to it. Right? Because yes, it seems like a lot of setup, doing all this, creating all this data, creating all these systems, but now when I want to add something new, I just drop the data that I want on it. That automatically makes the systems run. I don't have to tell them to run, and then they just work. And that's what's really cool about this stuff once you kind of grasp it and understand how this stuff is sort of set up. So please check it out. And I'm going to be around for questions if anyone has any. Thank you all for taking the time to attend the talk, and I hope you all have a fantastic Unite Sydney. Cheers.